Welcome again to today's class on statistics. In today's class, we want to discuss the topic analysis of bioassay. Yes, this is one of the statistical topic we have. This bioassay you are seeing is gotten from the word biological assay. So it is shortened to be bioassay. So biological assay is what we call bioassay. But before we go in details to discuss how we can analyze a statistical problem given to us on bioassay, let's first and foremost discuss what an assay mean. Yes, what does the word assay, what does it mean? An assay is a quantitative or qualitative test of a substance to determine its components by measuring its effect on a test of specimen against that of a standard substance. I take it again. An assay is a quantitative or qualitative test of a substance to determine its components by measuring its effect on a test of specimen against that of a standard substance. What do we try to explain? When you hear the word quantitative, it means that you are checking if the outcome you have is measurable. If the outcome you have is measurable, you can quantify it, you can measure it out and know the value it is. You say it's a quantitative. But when the outcome you got is not measurable, you can't quantify it, you can't know the value, amount it is, you say it's qualitative. Yes. So when we are checking the quantitative or the qualitative test of a substance to determine its components by measuring its effect on a test of specimen against that of a standard substance, we say you are discussing or you are experimenting on assay. Okay? Examples of assay. Examples. Number one, paternal assay. Paternal assay. Number two, stress assay. And number three, biological assay. Yes, these are examples of bioassay. These are examples of assays we have. Paternal assay, stress assay, biological assay, which we call bioassay. Now, in this video, we want to focus our study on analysis of bioassay. Let's first and foremost check out what does bioassay mean. Bioassay, as I stated before, that it can be called biological assay, simply mean you are experimenting with living tissues. You are experimenting, you are assaying the living tissues like plant, animal, bacteria. You are using any of these living organism to do your experiment. That is what we'll talk about bioassay. When we'll go into pharmacology in details, you'll be seeing a lot of terminology, in vitro, in vivo, and others. This is to tell you living tissues, the living organism are what used in such experiments. That means when you want to perform experiment on bioassay, three things are what you look at. Number one, you talk about what drug am I to use in such experiment. Another name for drug in this regard can be called the stimulus. The stimulus. You can also ask, what type of living organism am I talking about? Is it living organism, so to speak, or is it living tissue? Which one do I want to make use of? The living organism or tissue or organ, whichever one you want to use, but it must be a living thing, so to speak. Yes, it can be from plant or animal or from bacteria, etc. So from any living organism, so to speak. Then you now check the response. What is the response you get when this is put into this? So what are we trying to say? When you take a drug, when you want to perform experiment on bioassay, it involves or it comprises taking a drug or a stimulus and inject it into a living organism, living tissue, living organ, whatsoever, but it must be living, it must be alive. You understand? So you take the drug, inject it into that living thing, so to speak, and you check the response. What will it cause to that organism? Is it going to stop a particular thing, or is it going to cause a particular thing? That is what the response will be checking out. Remember, we said if we are checking whether it is yes, it's caused this, no, it does not cause this, yes, it wasn't this, no, it does not wasn't it, you are checking the qualitative aspect of it. Are you getting it? But if you are now checking the quantity, the amount, are you getting what I'm saying? At which it costs that particular thing, you say what? We are talking about the quantitative aspect. That is, you are trying to measure out the quantity, the level, the amount at which is able to cause that thing you are talking about. You get the point? Let's take, for example, Mr. A just made this hypothetical statement. What do we mean by hypothetical statement? It simply means he made a statement which he has not verified. That is, he just made a statement on what he think. Yes, he has not verified it. And that statement goes this way: that if you are having malaria caused by Plasmodium falciparum, yes, that what you do is get this leaf, use water to squeeze out the extract of it, and after squeezing out the extract of it, drink it for 3 days, and it will cure the malaria. Yes. How will you know what or if what the person just said, what Mr. A just said, is correct or is true? What do? You just do what he asks you to do. Get water and squeeze out the extract of this leaf. That extract of this leaf will be called the drug or the stimulus. Then drink it. In that case, human being is a living organism that is used in that experiment. So when you drink it, what will happen is we are looking for response. What type of response? Qualitative response, qualitative outcome, because it will not be measurable. All you are trying to check is after drinking it for 3 days, will the extract of this cure the malaria the person or the malaria patient have? Are you getting what I'm saying? Then after the 3 days, if he cures it, you say yes, this leaf contain anti-malaria agent. But after the 3 days of taking of this, and this malaria is getting worse and worse, it means that this leaf does not have any anti-malaria agent of it. Like the API of this is not anti-malaria agent. I get what I'm saying. So what you are focusing to discuss when you talk about qualitative is if it does stop or if it does not stop, if it cures or if it does not cure. That is just what they are checking out. You get the gist. But when you want to discuss the quantitative aspect, wow, you have to embark on experiments that will help you see how to read value the degree at which it cures malaria. You can also bring a standard anti-malaria drug like ACTs, artemether lumefantrine, brand of or type of anti-malaria drug, anti-malaria agent, so to speak. Okay, so what you need to do is you just the last time we performed experiments on checking the efficacy and potency of two drugs, comparing their efficacy and potency. We use some equipment like chymograph and others. You understand? And we use intestine of guinea pig. That means we are checking the antimotility of the agent, whether the agent can cause antimotility or not. Are you getting what I'm saying? So what I'm just trying to tell you is that there are equipments you have to get. You want to check the quantitative aspect. It is this equipment that will help you to read off or get the value at which, or the quantity or the degree at which this cures malaria or not. And you can even compare it with already existing anti-malaria agent like artemether lumefantrine, so as to know whether the extract of this is a better anti-malaria agent than artemether lumefantrine, or whether artemether lumefantrine is a better anti-malaria agent than it. This is what you will be able to get in quantitative aspect. So quantitative outcome or quantitative aspect of bioassay, the quantitative response of it, helps you to do comparison, helps you to know whether the test substance is more efficacious, more potent than what the standard own, or whether the standard own is more efficacious and more potent than the test substance. So there must be equipment you use. You don't just get the quantity aspect of it, the quantitative aspect of it, by merely giving it to the person. He drinks it, he say it stop malaria or it does not stop malaria, and you are getting the quantity aspect. No, you don't do that. You get equipment that will be reading off the degree at which it's a particular agent or not. Yes, you get equipment that will help you to do that. So we are saying in essence that drug or stimulus, living organism and response are the makeup of the structure of bioassay, are the makeup of the structure of what? Bioassay. So these three things make up bioassay. Remember, remember, when you are talking about qualitative, you are checking whether it cures this or it does not cure this. So it's not measurable. But when you are talking about quantitative outcome of it, it means you are checking the quantity at which, the degree, the extent at which it does a particular thing or not. And you must have equipment necessary for that, so as you'll be able to get it. If you do not have the necessary equipment needed for you to what? Get the quantitative aspect of it, you will not be able to get it. You can't get the quantitative aspect by merely giving the drug to that living organism and you get the quantitative. No, you have to bring needed or required equipment so as to get every information in terms of quantitative aspect needed. Okay, now let's look into some of the questions one can be asked in this topic, analysis of bioassay. Yes, let's look into some of the questions one can be asked in this topic. Number one is relative potency. Relative potency. One can be asked to find the relative potency, so to speak. This relative potency is denoted with this symbol equals to mean of the standard test all over mean of the what? Prepared test. This is the formula for finding relative potency. This is called mean of the standard test. This is called mean of the prepared test. Are you getting what I'm saying? So all you just need to do is that you say this equals to mean of standard test. Then this one is equals to mean of prepared test. Then another question one can be asked in this topic, analysis of bioassay, is confidence interval. Confidence interval. This confidence interval can be packaged this way. Yes. What do we mean by RU? RU simply means upper bound limit of the response. RU simply means upper bound limit of the response. So we call this upper what? Bound limit of the response. And we call this lower bound limit of the response. So how do we find that? To find that, you say the relative potency plus or minus bracket T level of significance all over 2 NES plus NP minus 2 times square root of variance of the relative potency. So what am I saying? Relative potency plus or minus bracket T alpha over 2 NES, that is sample size of the word standard, sample size of the prepared, minus 2 minus 2, then times this. That is how to what? To find the confidence interval. So this relative potency plus this whole value will be giving you the upper bound limit of the response, whereas this relative potency minus the whole of this value will be giving you lower bound limit of the response. Are you getting it? So you use the plus sign to get the upper and use the minus to get the what? Lower. Do you get what I'm saying? I'm just discussing possible questions they can ask you in this topic, analysis of bioassay. Another question they can ask you is variance of relative potency. Variance of relative potency. And it is S squared all over mean of the prepared test squared bracket. When you say S squared all over mean of the prepared test, you now say 1 over n plus relative potency squared all over what? N. So that is how to get it, where n will be equals to NP plus NS. When you add the sample size of the prepared test, with the sample size of the what? Standard. You see that prepared test is that extract I talk about. The standard is already existing one we know. I use a leaf to talk about the extract of a leaf is called prepared test. Then the standard, the artimetal olfactory own, the already existing one is the what? The standard. So when you add the sample size of prepared test plus the sample size of the standard together, you get n. But in a situation whereby NP is equals to NS, say automatically that it will be equals to n, the total sample size. A situation whereby this is equal to this, say is equal to what? The total sample size. Don't just add them again. You get the gist? Okay. Then that one there. Also, note that S squared is equals to SS squared plus SP squared all over NS plus NP minus 2. So the variance, this is the variance. So the total variance we are talking about is variance of the standard test squared plus variance of the prepared test squared all over sample size of the standard plus sample size of the prepared minus 2. You'll be able to get the value of S squared you have to put here. Are you getting what I'm saying? Then another thing that they can also ask you is the precision estimate. Precision estimate. How do we sort it out? When they ask you to get the precision estimate, it simply means the relative potency plus or minus square root of the variance of the relative potency. Wow. So precision estimates also have the upper bound limit of it and the lower bound limit of it. So when you get this plus this, you get the upper bound limit of it. When you now say this minus this, you get the lower bound limit of it. I'm speaking in parable now, right? Okay. We'll go to live question. For you to use the live question and see how you can appreciate this we talk about. We have a lot of things we need in this topic. You will need a 4-figure table containing the T distribution test, student T distribution test. We will need a 4-figure table containing student T distribution test. We need a calculator, a functional calculator. Yes, these are the two things we need to sort out questions in this topic. Okay, let's discuss this example we have on the board so as to understand how to solve question on analysis of bioassay. Remember, as I said, you will need a functional calculator, 4-figure table containing percentage points of T distribution. Like this one I have. Look at the percentage point, percentage points of the T distribution. These are the two things you need if you want to solve this question. Yes. Suppose we have two tests, where the first test is the prepared test. That means this first test is called prepared test, and the second is a standard test. That means this is my standard test. Okay. The following observations are made. So this is the second. I will just put it standard word test. This is a prepared word test. Okay. So all the places I am seeing one, I will now be changing it to what? Prepared test. And where I see two, I will change it to what? Standard test. It's very important to avoid confusion, because the formulas we have here is in terms of standard and prepared test. That is why I'm just taking this information down. Okay, they say set up 95% confidence interval for the test and calculate its relative potency, variance of relative potency. Now, when you see question on this topic, ask yourself, which among these can I answer sharp sharp? I can answer relative potency sharp sharp. Can you see that? And it is relative potency denoted with R this is equals to what? Mean of the standard all over mean of the what? Prepared test. Mean of the standard test all over mean of the prepared test. Mean of the standard test is given to be what? 18.39 all over 18.29. You get your answer. You now use your functional calculator, 18.39 divided by 18.29. That will be giving you 1.0055. So it does not have units. Yes, no unit. I have answered relative potency. I mark it good. Then I look for the next to answer. Let me go for, let's say, variance of relative potency. Let me take care of variance, because if I sort out variance of relative potency, it can make it easy for me to sort out this, and you can make it easy for me to sort out this. So let me sort out variance or relative potency. Yes, let me sort it out. Variance of relative potency is equals to, you see the formula now. So I will first of all get my S square. I will say S square is equals to, what is my SS squared? SS squared is 44.39. S square equals to SS square 44.39 plus SP squared equals to 72.96. Yes. Now say all over 10 plus 10 minus 2, that is 18. 10 plus 10 gives you 20 minus 2, 18. Okay, let me do it. 14.39 plus 72.96 divided by 18. That will be giving me 6.52 equal to 6.52. Wow, I've gotten my S squared, this value. So I will put it here now. Remember that in this question, any S is equal to any P equal to 10. So automatically it is equal to N. So we will not be adding the NS with any P for us to get our N, because of what? They are equal. Remember we said once the value of NP and NS are equal, don't add. Just say that they are equal to the total sample size N. Okay, so variance of relative potency should be 6.52. Remember, S square means we have gotten it already, so you shouldn't square it. That is where people or students do make that mistake, squaring this, forgetting that they got it by square way. All over mean of the prepared test. Mean of the prepared test is 18.29 squared, because it has squared. Bracket 1 over 10 plus, what did we get in our relative potency? Relative potency was 1.0055. Then we square it. We now say all over what? 10. So remember that this one is different. We did it first before checking out this. So watch what we will do now. You have to do it carefully. 6.52 divided by 18.29 squared. That will be giving you 0.0195. Bracket 1 over this, 0.1 plus 0.1005. No. We have to square this first before dividing by 10. 1.0055 squared divided by 10, that is 0.1011. Okay, so we now add it plus 0.1. So this plus this, it will give you 0.2011. I'll now say 0.2011. What will it give me? Times 0.0195. Okay, I will be having 0.00392. 0.00392. Still, it doesn't have units. So this is possible questions they can ask us in analysis of bioassay when we come to statistics. Are you getting it? Relative potency, confidence interval, variance or relative potency, precision what? Estimate. They can ask you that. So when you are getting any of these values, they are asking you, any of the answer to any of these parameters they are asking you. It is a way of getting quantitative aspect because you are getting the value of the variance of this precision estimate. So you are getting the quantitative aspect also, so to speak. So this must have been performed experimentally to get all these values we are talking about before we can now be doing all these calculations. You get what I'm saying? Okay. Guess the next we have to do. We can do precision estimate because it's simpler, because we have gotten variance of the relative potency. Look at variance of the relative potency. Are you getting it? So we can do this now. Then from there we now do confidence interval. So to do this, we'll do it as the last one. Okay, so discuss this precision estimate. We say the relative potency, which is 1.0055 plus or minus square root of variance of relative potency, which is 0.00392. We just got this variance of the relative potency. VAR, capital R, means variance of the relative potency. And so we'll be having them to go this way. Square root 0.00392 will be giving you 0.0626. Okay? 0.0626. So we now say 1.0055 plus 0.062 what? 6. That is the first value, or 1.0055 minus 0.0626. That is the second value. So when we talk about precision estimate, when we talk about precision, it has two values. To get the first value, let's check it out. 1.0055 plus 0.0626. That will give you 1.0681. And this is what we call the upper value of it. We call it the upper value of it. Then to get the other one, we say 1.0055 minus 0.0625. So this will be giving you 0.943. So the upper value on the upper bound limit and the what? The lower bound limit. So do well to still use your what? Calculator to cross-check this my solving so that to confirm it. If there is any place we encounter error there, please also let me know. Okay? Also let me know. Thank you. So we go to the last one, the confidence interval. How do we sort out the confidence interval? Oh yeah. Okay, so get the confidence interval. You need to know how to get this value you have to get from the table. Now, remember they say 95% confidence interval. That means your alpha will be equal to 100 minus 95. 100 you are using to minus 95 because this is in percent and total percentage is 100. So level of significance is gotten from, say, 100 minus confidence interval. So 100 minus 95% confidence interval will be giving you what? 5%, and is equal to 0.05. That is your level of significance. And so all you just need to do is to come here to get your T. Your T, 10 plus 10, 20. 20 minus 2, 18. Then 0.05 divided by 2. Alpha over 2 means 0.05 divided by 2. That will be giving you 0.025. Let me confirm. 0.05 divided by 2. 0.025. My head is already filled up. Okay? Okay, how do we sort it out? How do we sort it out? Go to your table. that place they wrote one tail, you will see where they wrote 0.025. Trace it down to 18. If you trace it down to 18, you'll be getting 2.10. You'll be writing 2.10. Go to your percentage point of the T distribution. Trace out 0.025 at one tail on, trace it down to 18. You have 2.10. That is just it, or no other thing. So my confidence interval will now be equals to 1.0055, that is the latent potency, plus or minus this one is 2.10 times square root of what? Square root of variance of the what? Latent potency. What is the variance of the latent potency? We just got this variance of latent potency. We got it to be 0.0626. We just got the variance of the latent potency. Okay? So 0.0626 is what we got. So the implication of it is that I have to multiply these two with my calculator. Okay, this should be in square root sign. 0.0626. Yes, I just checked the formula. So we now say square root of 0.0626. Square root of 0. Square root of variance of latent potency we got here gave us 0.0626. Are you getting it? We have gotten this now. We have gotten it. Square root of variance of latent potency 0.0626, so that we will not confuse ourselves. Okay? Yes. So what you need to do is that you use it to multiply this. You say 0.0626 times 2.10. It will give you 0.13146. 0.13146. Okay, I will now say 1.005 plus 0.1315 approximately. It will give you your R what? U. Then 1.0055 minus 0.1315. It will give you your RL, the lower aspect, the lower bound limits of the response. So let's check what it will give you. 1.0055 plus 0.1315. That will be giving you 1.137. No unit. Again, 1.0055 minus 0.1315. That will be giving you 0.874. Okay, so it means that your confidence interval is equal to, package it, 1.137 comma 0.874. So this is the upper value of it and this is the lower value of it. Upper value of it and the lower value of it. Okay, so that is just it. That is just it. Very simple. And I believe you understood this solving very well. If there is any point you did not get clearly, please use the comment box and ask your question. And that is how we call it a day to the topic analysis of bioassay. Yes. So feel free to follow us on YouTube, on our social network platforms. Follow us there. Yes. Share it to your friends. Yes, if you enjoy what you learn, share it to your friends so that they will also learn too. See you in our next class.